Hi, today let's have a look on this vintage static air temperature indicator. This one was manufactured in 78. First, let's open this thing to see what is inside. This thing is very nice. Okay, so first we can see that we have a servo control here, so this is the motor. There is here a dual potentiometer, and we have here a synchro transmitter. So this permits probably to have also a connection to a passive static temperature indicator. Okay, and we have an electronic side for the servo control amplifier. Okay, so let's have a look. We have one transistor here in black package. There is a small transformer, and we have another transistor. It's a very strange package, and it seems that we don't have anything else, but look at that. We have here two toroidal coils, this one and this one. So it seems that we have a magnetic amplifier. These two coils are actually saturable reactors. Very interesting. We have two wire-wound resistors here with a very high accuracy, 0.05%. It seems. The second one is expressed as 1 divided by 50%. So it seems this is 0.02% accuracy. I have actually only two transistors on that device. And the first thing I will do is to do the reverse engineering. I think it is not very complicated. And after that I will try to get it to work. We can see on the screen the schematic diagram of this indicator. This is mainly a servo amplifier. The input of the amplifier is here on the primary of this transformer. The feedback potentiometer is here. So this circuit is a part of a bridge actually. We can see the accurate resistors here. The motor is here. The motor is linked to this feedback potentiometer and also to the second half of the dual potentiometer here and to the synchro transmitter. The servo amplifier uses two transistors, this one and this one. This amplifier is a magnetic amplifier. This amplifier uses actually a positive feedback, which is done using this diode and this one. During the positive phase of the input voltage, there will be a conduction of this transistor. So this transistor will provide a DC current which flows through these two transformers. These are actually saturable reactors. Therefore, a current can flow from the power supply here to one coil or the other one and return to the other side of the power supply here. And this capacitor permits to tune this circuit to 400 Hz. There is a positive feedback because there is a DC current flowing through this coil or through the other one, so this permits to increase the saturation of the saturable reactors. For the test, I have connected the input here to this potentiometer. This potentiometer is supplied with two AC voltages out of phase. So therefore, the middle point of this potentiometer corresponds to a null voltage. Therefore, it is possible to change the phase. That's all for this static air indicator. Thank you for watching and see you next time for another video. Bye bye.